Okay guys, I'm sure you miss seeing my bright, beautiful face, but it's kind of hard to draw this on dry erase boards, so I'm just going to have to teach this from here. So this is a review on how to graph and how to identify features of graphs. Okay, so if I look at this, I can see right away that my A term is 4. So if A is 4, I know that's going to be a vertical stretch of 4. Okay, now, I also know that this is going to open upward. So right away, I know that it's going to open up. And the way I know that it's opening up is that A is a positive number. So I have no negative in front of there. Okay, so next I need to know the vertex. So I could complete the square and put it into vertex form, or I could use the new thing that we learned. So we talked about, in order to find the axis of symmetry, I can use the equation negative b over 2a. Okay, so I know my b term here is negative 16, so I just plug that in. So negative 16 over 2a, so that gives me 16 over 8, or 2. So therefore, my axis of symmetry, I always give it in terms of x equals. Okay, so I know that my axis of symmetry is going to be x equals 2. All right, so I can just jot that here, so I can draw this in so I know where my line of reflection is going to be. And I know that it's x equals 2. Okay, so once I get that, and I know that my vertex is going to be at 2 something, because I know my vertex needs to lie on this line. So when I'm trying to think what is it going to go into, I can then plug in 2 into the equation. So I have 4 times 2 squared minus 16 times 2 plus 3. Order of operations, I have to square this first. So 4 times 4. So I have 16 minus 32 plus 3. So negative 16 plus 3, I get negative 13. Okay, so I now know that my y value is negative 13. So I can plot my vertex is actually at 2, and it's slightly off my graph here, down at negative 13. So 2, negative 13. Okay, now, in order to graph this, I need some other points, and I do know that my y-intercept here is 3. So I know when it's in standard form, this term right here gives me the y-intercept, so I know it's at 3. Now, if this is the axis of symmetry, that's the line of reflection. So if there's a point that's 2 spaces to the left of the axis, there's another point over here. So once I have 3 points, as long as I have the vertex and 2 other points, I can go ahead and draw my curve. So sorry, it's not going to be super pretty, but I know it's going to go down like this, back up. All right, so maybe not the best curve in the world, but you get the idea. All right, so I know it opens up. I just found my vertex. I found my axis of symmetry. So now I'm looking at the domain. So hopefully you realize by now the domain is always negative infinity to positive infinity. That just means I can plug any number in for x. So any number I want. Negative 1,000,000, negative 6, 0, 1,000,000. So for the range. I have to look, what is the lowest possible value? So the lowest possible y value down here is negative 13. So therefore for my range, the lowest possible value is going to be negative 13. But you can see for y values, it goes from negative 13 all the way up to infinity. Okay, so remember, we said that before, maybe last year you wrote it something like this. Y is greater than or equal to negative 13. So this greater than or equal to symbol, that's where the bracket comes from. So the equal to tells you that it's a bracket, and then you just say it goes from negative 13 up until positive infinity, which is forever. Okay, so from there I can look at the maximum or minimum. So I see that it's going to have a minimum value, and I look to see how far down does the minimum go. So the minimum value is actually negative 13. So I always give a minimum and a maximum in terms of y. So axis of symmetry is in terms of x, And maximum or minimum is in terms of y, because it's how high or low on the graph can it go. All right, so intervals of increase and decrease. So we're going to look at this. Okay, so imagine that this was a rope swing, and I was going to swing from this y-intercept over to here. Okay, so imagine if I started swinging from here, from 0 all the way until 2. Let's say this is time. So from 0 to 2 seconds, I am swinging downward. Okay, so again, you're just looking at the x-axis. So from here, I'm seeing at what point is y decreasing. So y is decreasing from x equals 0 to x equals 2. Okay, now, if I was looking at this point, then I would say then from 2 seconds to 4 seconds, I am now increasing. So I go from here to here. Okay, now, and the actual graph, I know that it goes from negative infinity. So my area of decrease, I'm going to decrease from negative infinity, so all the way. All the time I'm decreasing, 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 decreasing until the axis of symmetry. So I decrease from there until 2. Now where do I increase from? I'm going to increase starting at 2 and then continue to infinity. So I'm going to use a parenthesis here because it's not actually going to include that point. Seems kind of strange, but at that point I can't really say I'm increasing or decreasing because that's my turning point. So it decreases until it gets to this axis of symmetry, and once I reach the axis of symmetry, then it starts increasing. Alright, so my end behavior. Whenever I do my end behavior, I'm going to write as x approaches infinity, y, and as x approaches negative infinity, y. Okay, so if I look at this, if I look at the end, so when I'm talking about end behavior, I am talking about the ends. So let's look at the ends. Okay, so I can see that both ends are going up. So as x approaches infinity, so I put in 2, I put in 4, 6, 10, 20. The higher number I put in for x, what happens to my output value? And hopefully you answered, well, it continues to increase. So as x goes to positive infinity, y goes to positive infinity. If I look back at the other end, what happens as x goes to negative infinity? So as x gets lower and lower, what happens to y? And y is still going to positive infinity. So the end behavior, what's happening at the ends, y is always increasing. Y is getting higher and higher no matter if I'm looking to the left or I am looking to the right.